Nice. In our last lesson, we learned about polar coordinate systems, and today we're going to apply that and take a look at some functions in polar coordinates. All right, it's going to be uh, kind of weird and a little strange thinking about these coordinates and how they work and putting the functions in there, things that we're familiar with, sine and cosine, but what do they look like here? Just keep in mind what the coordinates mean, that you're dealing with radius and angle. And so if you're putting in, some value for theta, theta is the angle. That's how far you're going around. You think of putting that into sine or cosine or tangent, whatever it might be, and then okay, what would the output be? And that would give you the radius, right? Um, and so we're going to use some of our standard points like zero. If we have theta is zero, what is the point? If we have theta is pi over two, what's the outcome or what's the output of that kind of function? Right. And so here's an example. We're going to graph the polar function or graph on polar coordinates, right? R equals f theta, and f theta is 3 minus 3 sine of theta. Okay. Um, because we've got R here where, it's 246, it's not in terms of pi. We're going to have our output in terms of just decimal numbers. Okay. And so what you would do is you would put these into your calculator, or yeah, I mean, to get the decimals here, you're going to need a calculator, and just fill out this table and then graph the points and see what it ends up looking like. So I'll do that now. So I've put the points in here, the output, but I've also graphed it on rectangular coordinates just to see what it looks like, right? So this makes sense, of course, right? So we're starting it when we have zero, it has a midline of three. So it starts at three, it goes down to zero, and then goes to back to three when we get to pi, etc. Then we get up to six. Six is the maximum, and then back down to three at the midline. Okay, so here's what that means. Let's plot these points now, and remember, this is zero. This is pi over two. This is pi, right? So for example, just to plot a couple of these, at zero, it's going to be at three. So angle zero. Let me do this in red so it really shows up. Okay. At pi over 2, r is 0. That means like when I go here on this line, right, because this is pi over 2, this angle, pi over 2, I'm at 0. Okay. And so it'll look like that. And then at pi, when I've gone all the way at like 180 degrees, I'm back at 3. So that's right here. And then at 3 pi over 2, right, so that's going all the way around. 3 pi over 2, that's the angle. And then where do I go? What's the radius at that point? It's 6. It's positive 6. So this is going to be interesting, right? We should fill out the other numbers and see what this looks like. So when I connect the dots, this is what I get. And it kind of looks like a heart, doesn't it? Right? It's called the cardioid function. But it's a type of a cardioid function. Coming from a word that means heart. Cardio, like cardiology, cardiac arrest, etc. But take a look at what's going on. Again, we're starting here at 3, and then sine goes down to 0. So that means that as this angle goes around, it goes down to 0. So as the angle's turning, it's shrinking, it's getting less. And then as the angle is continuing to turn, it's increasing, right? So it goes from 0 all the way up to 6 by the time we get to 3 pi over 2, which is here, right? This is 3 pi over 2. So it's increasing as it goes around. So as we're turning, it's going around, up, and then back down to 3 by the time we get back to 2 pi. So for these types of questions, I recommend graphing points and keeping in mind this function, what this looks like, right? So again, 3 down to 0, up to 6, and back to 3, 3 to 0, back to 3, up to 6, and then back down to 3. One note that Mr. Passwater is giving us here, when it comes to these types of graphs, you're not going to have to draw a graph on the AP test, but you are going to have to be able to recognize them to pick out which function goes with which graph, etc. Right? So you're expected to understand all that. Um, yeah, and so sometimes you can solve this just by putting in a few of the um, a few of the coordinates by solving for a few of these and seeing where does it turn out. Is it on the graph or not? So, for example, here's another example. Here's another example. Example two. A figure shows the graph of the polar function f theta over the from 0 to 2 pi in the polar coordinate system. Which graph is this? Wait, so which one do we have here? Notice what's happening here. As it turns from 0 to 2 pi, it starts at 0 and then goes out to a maximum of 3 and then comes back to 0. Notice all these have an amplitude of 3. And notice it does that 3 times. So it goes through 3 cycles within 2 pi. And so notice that for all of these, the b, right, this multiplier in here is also 3, right? And so it's increasing. So by the time theta equals 2 pi, or about, 2 pi over 3, it's already gone around one full rotation. And so which of these could be an expression for f of theta? Well, look, at 0, at the angle 0, it's at 0. There's no phase shift, right? And so that would mean that the cosine graphs are out because cosine at 0 is not 0. Cosine of 0 would be 3. So these would kind of look like this, right? This one, -3 cosine 3 theta. This one would be starting here like that. This one would be starting at +3, going like that. So these two are out. And so we're left with these two. 3 sine of 3 theta looks like this. It goes positive, etc. This one goes -3 sine of 3 theta. So it starts at negative and then goes this way. But what happens here? This one goes, right, at least what it looks like, immediately it starts going um, like it starts going positive. Right? You could graph f of pi over 6. So let's put pi over 6 in here and see what happens. So if we do 3 sine, or let's try -3 sine. We're going to rule out b, by the way. The answer is a. -3 sine of 3 pi over 6. Okay, so 3 pi over 6 would be pi over 2. And so sine of pi over 2 is 1. So sine of pi over 2, -3, would just be -3. And so when I get to pi over 2, which is here, I have -3, which is actually down there. Oh, nope, sorry. So pi over 2, because I plugged in pi over 6, right? Pi over 6 is this angle here. So when you plug in pi over 6, we have +3. And so that means that b is ruled out, and the answer's got to be a. By plugging in those numbers, I forgot the input, right? The input into our function that we have here is pi over 6. All right, and so you get this pedal looking type function when we do this. Let's take a look at example 3. Here we have a function. Again, the range, the domain here is 0 to 2 pi, polar coordinate system. So what graph could this be? We've got a few options. Um, we've got sine, cosine. It looks like there's a midline shift, so we got to pay attention to that. So let's see what this would look like. I don't know, let's pick this one. So it's 2 minus 4 cosine theta. So it's a midline of 2, and it starts -4. So, cosine of 0 is 1. So this would start at -2 and go up to 2 and then go up to 6. And it would look like this, right? uh, and so It doesn't look like that's where we are though, right? Because we can tell that when this starts, um, it would be here, so -2. So it here, it would end up being, over there like that. Actually, maybe this could work. Let's see how this plays out. Oh, but the problem is, try plugging in something like, pi, pi over 2 at the position pi over 2. Right? So when you plug in the angle pi over 2 into this, pi over 2 would be 0, right? And but if you plug in 0 for this, then no, sorry, cosine of pi over 2 is 0. So then 2 minus 0. So this is um, whoops, at pi over 2. You would be at positive 2. So then that would mean that we should be around at pi over 2 and then there at 2, but that's not where it is. When we're at pi over 2, where is this? It's actually down here. It's -2. Okay, and that wouldn't give us this either. This would be this same graph just, shifted up. Um, or no, actually it would be flipped, right? Um, so that's not going to work either. But let's take a look then at these two over here. Uh, so we'd have 2 plus 4 sine of theta. So how is this going to work? Um, 2 plus 4 sine theta, it's a sine graph, and it's going to be starting at 2 because standard sine function starts at 2, and it's going to be going up to 6 and down to -2. And since it's plus, it would just be like this. Right? And so when we look at, for example, pi over 2, um, pi over 2 would be 6. That's right here. But when I look at this, when I get to pi over 2, I'm not at 6. Okay, so let's try the next one. It would be the same thing, except it's just reversed, going down from -2 up to 6. And so let's see, starts at 2, right? So 0 starts at 2. When it's at pi over 2, that's over here, it's at -2. So that would be pi over 2 to -2. So this is how you graph, right? The negative down there. And then it gets back to passes 0 again. So it goes through 0, passes through 0 again. That's here. At pi, it's over at 2. It's at -2, right? Or no, sorry, it's just 2, positive 2. That's how the radius thing works. And then it goes up to 6 when it's at 3 pi over 2. So that's here. So this is 3 pi over 2 comma 6. That works. And so the answer is going to be B for example 3. All right, let's take a look at example 4. I've already drawn the function here because they've given to us that this is -3 sine of theta. Okay, so there's no midline shifts, it's -3, so it looks like this. And we want to know basically on what interval does this graph show up? On what interval does it look like this? Okay, well, this is interesting, right? So it starts at 0, and then when we get to the point here, this is pi over 2. So when we're at from 0 to pi over 2, it is decreasing to -3. So 0, and immediately it starts decreasing to -3. So this is where -3 is. This is pi over 2, comma, -3, right? So pi over 2, 3 would be up here, but we're reversed negative down there. And then, so from pi over 2 to pi, we're going from -3 to 0. So that would actually look like this. Okay, so that's um, our next piece of the graph. So we found the answer. This would be from pi over 2 to pi. But watch what happens again here. So from pi to 2 pi over 3, notice it's going from 0 to 3. That would actually follow this same pattern. So it would end up going down. And then from 2 pi over, or 3 pi over 2 down to 2 pi, again, it's going from 3 to 0. So that would be from 3 to 0. The problem is I don't have 3 pi over 2 to 2 pi as one of my options. And so the answer here has to be B. Example 5, similar kind of situation where they give me a function and I've got to find, okay, where's the domain of the portion that they have graphed here. And we're looking at, so I've already graphed this and I used, you know, 3 theta to solve to find out where it is at each of these points. And so what this looks like, right? Again, so this starts when we have an input theta of 0, then I'm at 3. So that's like this, right? 0, comma 3. And then it's decreasing. So by the time it gets to pi over 6, it's at 0. And this is pi over 6 right here. So it actually gets, and that looks like that. It looks like 0 to pi over 6. Right? And I think that's what the answer is. The answer is D, 0 to pi over 6. You could continue. So from pi over 6 to pi over 3, pi over 3 is here. But at pi over 3, it's down at um, negative 3. And so that would end up being like this. So this would then continue like that. And then, uh, yeah. So anyway, it would end up continuing in this pedal type uh, function. And so what we actually get, this one is very helpful for the next function, because it ends up kind of looking like this, right? And so they've given us this function. They've graphed the whole thing. They got points A, B, C, D, etc. And they're telling us here, so instead of it being the same as before, it just has a different amplitude, 6. Uh, and so if we restrict the domain to pi over 3 to 2 pi over 3, so what does that mean for us? That's from here to here. So what would that be? We should draw this. Okay, so pi over 3, this is where pi over 3 is, right? But we don't have anything here, so we're talking about this from here. So then when we get to pi over 2, it's at 0. So pi over 2 is this, and we're at 0 for that point. And then from pi over 2 to 2 pi over 3, that's increasing from 0 up to 6. And so this is 2 pi over 3 here, and we're at that. So this is increasing. So this whole thing that I've outlined in red, that's that whole portion from pi over 3 to 2 pi over 3 of this function that they've given us here. Now they say one of the pieces of the portion of this graph is given from C to D in quadrant 3. Yeah, okay, get that. What is the rest of this piece? Well, we would say from D to A in quadrant 2. And that is the answer C. And so, again, the keys to this are um, paying attention to the coordinates and what the coordinates mean and relating them back to the graphs the way we know how to do them within our rectangular coordinates using sine and cosine, etc. And then we can go back and forth between the two, being really careful about, again, the meaning of the coordinates, what they mean, the angle and the radius, what it means to have a negative radius, flipping back and forth, etc. So pay attention to the details and it all works out. Thanks for watching. Don't forget to like and subscribe.